So this video is going to show you how to get what we call an orthographic dimensioned view of one of your Solidworks models. Now, an orthographic is like a blueprint, it's like a plan, and you have dimensions on it, and it shows normally a top, a front, and a side view of the part you intend to build. And it's there so that you can kind of hand it to a workshop or manufacturing facility to get it built, and they can take all the key information off it that they need. Now, before we go ahead and do this, obviously open up the part that you want to get a drawing of. If you want to do the whole assembly, then you need the whole assembly open. If you wanted just an individual part, then it's important that you open just that separate component before doing this process. But whether you're doing the whole assembly or just a part, the method that I'm about to show you is the same. The very first thing you need to do is ensure that your views are all aligned. And what I mean by that is go up to your little view cube up here and just click on a flat face, all right? Now, there's a problem with my model at the moment. When I look at it from the front by clicking that front face, my model doesn't appear front ways on. And this happens quite often with assemblies. And the problem is if I then make a drawing of this, all my drawings will be wonky, like this view here, and it's not how an orthographic should look. But we can change that, thankfully. So to do that, you just find a flat surface on your object that is what you would call should be front facing, so say this one here, and right click on it. And then you've got this tool here that says normal to, okay? And what that will do is it will adjust your view so you're looking at it dead flat on, you're looking at it normal to that view. If you now go up to your cube, click the little arrow, you may need to click this little here arrow to the right that says more options, and you'll get this separate window appear. Sorry, it's just disappeared. So let's do that again. So this one, arrow for more options. Right, you've got this option, update standard views. So click that and it will say, right, select the standard view you would like to assign the current view to. So I'm just going to click front. And it will say changing it, blah, blah, blah. We'll change, just click yes, that's fine. Now what happens is everything is orientated to that. So that is now my front. If I go to my view cube and rotate it and click on this side, you can see I'm looking at it dead end ways on. And if I look on the top, I'm looking at it from the top, as you would expect. Everything is aligned. It's really important you do that before you go on to doing the drawing. Okay, right, once you've done that bit, save your work. Always a good idea. And the easiest way to do this is to go up to the file menu, and you've got an option that says make drawing from assembly. If you've got just a single part open, it will say make drawing from part. So I'm going to click make drawing from assembly. I would recommend browsing and choosing A3 with land in the title, which means landscape, and open that and then click OK. Just because this will suit the format of the PowerPoint that we're using better, because it's the same orientation. And all we're going to do now is choose our first view. Now, it should show them on the right-hand side. So I'm going to pick front, and all you do is drag it out. And don't worry about the size of it for now, because we can change that in a minute. And you'll see if you move your mouse off to the right, it will give you the top-down view. If I move and click, if I move down here, it will give me my side-on view and click. And then what we like to do is put in what we call an isometric, a 3D view as well, because that helps engineers visualize it in the third dimension. So we click and place that. You only need 4 views, so when you've got 4, just click the tick, because the idea is that, oh sorry, just click, there we go, click that tick up there. The idea is that if you've put sufficient dimensions on all 4 of these views, you should be able to tell from one of these views any information that you need. Right, we need to make this page a little bit easier to work with. First thing I'm going to do is delete this stupid border and stuff. Now in industry you'd keep that and you'd write like on here who did the drawing, when did they draw it, when's it got to be made by. We don't need that for your PowerPoint. So to get rid of that, just right click on sheet format over here and choose delete. Just click yes. That'll make your page a bit nicer. Now the problem is these drawings are done to scale, and that scale is not right for this page, it's zoomed out. So if you click the original view you put, just in this sort of border area, you'll see you get these options on the left, and if you go down, it's set use sheet scale at the moment. You can also choose a custom scale. So I'm going to try 1:2, which should make it slightly more than twice the size it is before. Now if you pick the original one, So the very first view you placed, you'll see that the other 3 views all change their size in sympathy. If you're happy with the scale, click the tick. If you're not, obviously change it. You may need to drag your views over. So all you do is hover where there's a dotted line and pull it along. So let's try that again. There we go. Here. And we want to sort of space them equally on the page. Now it's important that the 3 views here on the left are all the same scale, but if you didn't have enough space with this third guy down here, you could just click on that one on its own and then go and change the scale of that one manually. So you could do one manual scale. I'm going to make that 1:4. Just that view. Okay, that just looks a bit better on the page because all my dimensions are going to go on these 3 drawings. Right, good. When you've done that, click a tick if you need to. What's really cool about this, by the way, just if you're interested, if you were to go and modify your model, like change something, the drawing will update automatically. So all the geometry on here will change. So you can just print it off again, which is really handy. Anyway, we need to put some dimensions and annotation on here so that an engineer or manufacturing facility could follow it. So annotation is all done with the annotation tab. First thing we're going to start with is dimensions. Now, smart dimension is the one you want. I don't know why my view's all weird. There we go, smart dimension. And what we're going to do is just, for your coursework really at GCSE level, you just need to put on the major dimensions that would help people build it. So I'm going to go, right, click here and click here. That shows how big that is. Okay, that's fine. If you, sorry, my computer's very slow. It's trying to do a video on this at the same time. Good, so that's fine, click the tick. Maybe I want to know how long this part is from here to here. So smart dimension, so do the same, click, click, place your view. You can override the value, by the way. So if we knew we wanted this to be 130, for instance, we could just click override and just type in 130, which is really handy. So obviously we might want to do the same on this one, round it up to what would seem like a more sensible manufacturing number. I don't know, 108. Okay, it's quite handy, but obviously if it needs to be the dimension it does, then don't change it. If you want to dimension something round, it's the same process, smart dimension, but just click on the round thing and move away, and you'll see it produces that little diameter symbol. So we know that that hole needs to be 4, that one needs to be 4, this one needs to be 6. Okay, so all we're doing is going around putting key information on that is helpful for building this product. Okay, I'm not going to do all of it. You just Control Z if you make a mistake. But what I am going to do is I'm going to spread them around different views. So for instance, this view is no good at telling me how thick this piece is. I can only tell how thick that material is by drawing on this view. So I'm going to click between here and here. So I know that that is 8mm thick. And I'm going to click between there and there. And again, I'm going to bring that out and make sure your dimensions are in a place where they're visible. Click the tick. Okay. Again, from the front, I might not know what diameter this is. So I'm going to just put my smart dimension on here. Click on that circle. I can select it. There we go. So I know it's a radius of 54.12. Maybe I want to know how far apart those 2 holes are. So I just click the 2 holes. Oh, this is painfully slow, I do apologise. Okay, sorry, I have to do that again. Yeah, if you want to sort of show how far between 2 holes, you just click one circle, click another, there we go. So I know that the distance between those 2 holes centres is 50. And basically, go around your model and put in as many dimensions as you can across the 3 different views to show what sizes this model should be, so that someone could have a chance of following in the workshop and building them. Okay. Final thing, I wouldn't bother putting dimensions on this 3D view down here. You don't need to do that. But what we do need to do is perhaps add some basic annotation and other information that might help with the manufacturing. So with my robot grabber claw here, it's all going to be 3D printed. So we have got, you'll see notes up here under the annotate tab. So we've got note. Again, super slow. You can choose your type of note. I want one that's got like a leader, an arrow on it. So I'm going to click that. And I'm just going to click where I want my note to point to. So I'm going to point it to there. Click down here. And then type what I want it to say. So I'm going to say 3D printed PLA. I don't know, 0.2mm layer height, whatever. Okay, that's just instructions to whoever's manufacturing it. I might want to go around and go, right, well, I could laser cut these bits, so I'm going to put another note on here. Okay, and laser cut 8mm perspex. And I might go, these are just holes at the moment, where in real life they'd actually have bolts in them, so I might go, let's put another note on. What kind of note? I want the leader one. So click on that bolt hole, bring it down. That's going to be M4 bolt with nylock nut. Okay, so I'm just putting information that would help people build this and assemble it. And again, distribute that around your view. Remember, this is supposed to be a plan to help someone make it. It shouldn't necessarily be explaining how it works or what happens. The more information you can put on, the better, but obviously you don't want to overcrowd your view. Okay, you might also want to put a title on. So again, under note is the easiest way. Just do a note, but without a title. So you've got, I don't know, just click anywhere to type a regular note. Look, so this could be grabber claw prosthetic assembly drawing version 1.1. Okay, put that up in the top right. Oh, sorry, there we go. And basically that's it. That is the process of producing a working drawing. I wouldn't call this finished. I'd say there's still plenty more dimensions I need to put on here. There are some other things that may be useful for you to do. So for instance, if I double click on this view, you see these options over here, just to show you what they do. You can color it in, which might be quite nice to bolden the page. You can color it without lines. You can click this one, which shows hidden detail. Now, if I zoom in, what hidden detail means is it will show components on the inside. So you can see a dotted outline of the battery pack and the switch and all the bearings and stuff that are inside here. That might be really useful if you're trying to explain some more detail. So I'll leave it down to you to choose those and customize. Beyond that, it's just a case of getting that into your PowerPoint. Okay, so I'll leave it down to you how you want to present it. Get the scale, get the dimensions, get everything done. Make sure you save it. And then the problem with importing it into your PowerPoint is it can look a little bit washed out if you just do a print screen. All right, so when you save, you can go to Save As, and I'm just going to put this in my documents so I can illustrate it. You can save as a JPEG. And the reason I'm going to show you to save it as a picture is when we put that into PowerPoint, we can get rid of this moldy yellow background and make it look really professional. So let's load up PowerPoint. I'm at the limit of what my computer can do here. It's grinding to a halt. Okay, so we've got our page. Now if I insert, rather than doing a print screen or a window snipping tool, if I insert that picture, oh, come on, insert picture from this device, man alive. Downloads, where did I put it? Documents. Grabber assembly, there we go. Insert. Excellent. Okay, in fact, actually, what's even better about doing it as a JPEG, can you see it's automatically cropped everything? It's automatically got rid of that yellow background and everything's in a nice high resolution. Obviously, you would want to then perhaps select this picture format, crop, and then use the cropping tool to make this the right size as the page. Okay. But if your page is set to A3 in PowerPoint anyway, it should fill it up perfectly, okay? Now, how much do you need to do? It depends whether you're doing GCSE or A-level. I would say at GCSE, I would definitely do one of these for the entire assembly, and I'd probably then pick maybe one or two really key parts. So say like this lever here, or this tunnel section here, and then do another dimension drawing for those bits just on their own. So you have maybe 1 or 2 pages of working drawings, okay? But that is the method. So I know that's quite a long video, but you need to produce that. And at A level, I would say you possibly need to present a working drawing for each of the component parts you're going to make within reason. But it's fine to include several parts on one page. All right, I can't possibly cover everything in this video, but that does the basics. So good luck, get your screenshots, follow those tips. And this really is a big mark earner, by the way, whether it's GCSE or A-level. Presenting your work like this, it's your CAD model, you spent a lot of time doing it. Get the marks that you deserve by handing in these pictures.